Okay, I think we'll start now. Last week I know you guys had less time to do the homework. So if you guys have any questions about this, we could go over it. If not, we'll just move on to the lesson for today.
I had a question about the seventh one. I didn't really know how to do that one. I was wondering if you could walk through it.
This one, like VI.
No, the last one.
Oh, okay. Um, okay, let me write it down. So 1 over x root 2 plus 1 over y times root 2 is equal to 1 over 3 root 2 and 1 over 6 root 2. So are you familiar with like solving systems of equations?
Yeah,
Okay.
how to solve that.
Okay, so what we're gonna do is let's say 1 over x root 2 is equal to a, and 1 over y root 2 is equal to b. So then we could say that a plus b is equal to 1 over 3 root 2. So this is this first equation over here. And then the second equation would be a minus b is equal to 1 over 6 root 2. So then if we add these two equations together, we get that. So let's add these. 2a is equal to 1 over 3 root 2 plus 1 over 6 root 2. So did that make sense, what we did so far?
Oh yeah, that makes sense. So then you would just simplify the right side and then solve the equation. Okay, that makes sense.
Okay. You guys learned how to like uh, rationalize radical fractions, right, last week? Like how to turn this into.
Yeah, yeah, I know how to rationalize.
Okay. Yeah, so you just rationalize this side, then you could solve for a. From there, you could solve for x, and then solve for b, and then solve for y. Okay. Um, did you have any more questions on the homework? Okay. If not, I'll just move on to the lesson for today. Um, we'll be starting relatively easier. And the first thing we'll talk about is the Pythagorean theorem. So basically, the Pythagorean theorem tells us that if we have a right triangle, then a squared plus b squared is equal to c squared, where a and b are the side lengths and c is the longest side. And we call the triple of numbers ABC a Pythagorean triple. So over here, we have some examples of Pythagorean triples. You can verify that they're Pythagorean triples just by adding like the squares of the first two numbers and seeing if it's equal to the square of the third number. Okay. So I'll give you guys 2 minutes to work on these problems. And when you're done, you could send me a private message. And also, if you had any questions about what I just explained, feel free to ask me. Yeah, for the first one, both of you guys are right. The missing side length is 6. And I'll give you some more time to work on the second problem. Maybe like 30 seconds. Okay, so for the second one, yeah, so for the second one, you guys had the right idea. But let's say you had this question on a test. I'll just show you how you would sort of write up the solution to that. Okay, here we go. So what the Pythagorean theorem tells us is that for any triangle to be a right triangle, you must have a squared plus b squared is equal to c squared. So if a squared plus b squared is equal to c squared, that means that the triangle is right. And also, if the triangle is right, that means that we need to have a squared plus b squared is equal to c squared. So basically, it's just telling us that this relationship can only be true in right triangles. So to check whether this is a right triangle, we need to see if a squared plus b squared is equal to c squared, where c is the hypotenuse, which is also the longest side. So that means we need to check whether 3 squared plus 4 squared is equal to 6 squared. Right? Since if this was a right triangle, 6 would be our hypotenuse since it's the longest side. But you can check that the left side is equal to 25, while the right side is 36. So obviously this is false, which means that the triangle isn't right. Okay, so do you guys have any questions about this? Okay, so let's move on. So now we're going to be talking about scaling Pythagorean triples. So on the slide where I introduced Pythagorean triples, I talked about primitive triples. And this sounds fancy, but it's basically just when the sides A, B, and C are relatively prime. So do you guys know what relatively prime means? Okay. Basically when three numbers are relatively prime, it just means that their GCDs are all 1. So A, B, C is relatively prime. When GCD of A and B is equal to GCD of B and C equal to GCD AC is equal to 1. This just means that these three numbers share any common factors. So to this notion of scaling Pythagorean triples, it's just when we multiply all the side lengths of a primitive triple by a certain positive number. So let's look at the first example. E4, 5. So we know that this Pythagorean triple is primitive because GCD of 3 and 4 is 1, the GCD of 3 and 5 is 1, and the GCD of 4 and 5 is 1. So let's say we want to scale this triangle, right? That basically means we can multiply all the side lengths of this primitive Pythagorean triple by the same number. So we just get a bigger version of the same triangle. So let's say we multiply all the sides by 2, then we get 6, 8, and 10. So when we multiply all the sides by the same number, we also get a Pythagorean triple. And you can check this. You can check that this is a right triangle because squared plus 8 squared is equal to 10 squared. So you could basically just multiply the sides of any primitive triple by any real number, and you'll get another triangle. Okay, so now this algorithm that I'll give you guys is a way that you can generate any Pythagorean triples. Let me just take a screenshot. Okay. So what I mean when I say that you can generate Pythagorean triples is that you can plug in any two numbers, m and n, and you can get three numbers that whose side lengths form a right triangle. So let's say we pick m is equal to 5 and n is equal to 1. Or let's say n is equal to 4. Then by plugging into this formula over here, we get a is equal to 5 squared minus 4 squared, which is equal to 9. B is equal to 2 times 5 times 4, which is 40. And c is equal to 4 squared plus 5 squared, which is 41. And you can actually check that these three numbers, they form a Pythagorean triple. So 9 squared plus 40 squared is equal to 41 squared. So did that make sense?
Yeah, it made sense.
Okay. And this isn't that important, but it's just another interesting thing you can do to get Pythagorean triples. So let's say we take some odd number, 2n plus 1. And you guys know this is just a general form of an odd number. So if you square this odd number and you FOIL it out, you get 4n squared plus 4n plus 1. Oh, okay. So what I'm saying is that you can write this as the sum of two consecutive integers. So consecutive integers, you probably already know, are two integers that are right next to each other. So a plus 1 is equal to 4n squared plus 4n plus 1. Or equivalently, 2a is equal to 4n squared plus 4n. And that means dividing both sides by 2, a is equal to 2n squared plus 2n. So you can write this perfect square over here as 2n squared plus 2n plus 2n squared plus 2n plus 1. And our original odd number was 2n plus 1. So if you do this, you also get a pair of Pythagorean. You also get a triple that forms a right triangle. And you can manually check that just by squaring these first two numbers and checking that it's equal to this number. Okay, so did that make sense? Does anyone have any questions? Okay. So now we'll be looking at the Pythagorean theorem for 3D shapes. And this is basically just what you do when you have a rectangular prism. So let me just take this here. So basically, when you have a rectangular prism with length L, width W, and height H, you can find the length of the space diagonal of the prism using the Pythagorean theorem. And when you do that, it gives you that L squared plus W squared plus H squared is equal to D squared, where D is the length of the diagonal. And that may seem like intuitively correct, but I'll be showing you how exactly they got that formula. Oops. So first thing we can do is let's draw our own rectangular prism. It has length L, width W, and height H. And what we want is the length of the space diagonal. So in order to use the Pythagorean theorem to find the length of the space diagonal, we need to know the lengths of the two bases of the right triangle that the diagonal is the hypotenuse of. So from here, it seems like this edge over here could be one of the bases for the right triangle. And this base over here has height h. And then the second base of the right triangle would be this one over here. And we know that this is a right angle. This angle over here is a right angle, since we know that the plane of this base over here is perpendicular to the plane of this base over here. So knowing that these two sides are the bases of the right triangle over here, all we need is the length of this one over here. So can you guys tell me what the length of this yellow base over here would be? Oh no, just in terms of L and W. So maybe I'll zoom in on the face. So remember that the yellow diagonal over there is just the diagonal of the rectangle that forms the base. Right? So this would be W and this would be L. If we just look at the floor. So what would this yellow length over here be? Yeah, it would be square root of L squared plus W squared. Because we know that A squared plus B squared is equal to C squared. So C would be the square root of A squared plus B squared. Right? So we know that the yellow diagonal is L squared plus W squared. Or square root of L squared plus W squared. And we know that the second base has length h. So if we only focus on that right triangle, so let me draw it out. It has height h, length L squared plus W squared. And the diagonal would have, let's say this is D. Then we know D squared would be equal to H squared plus square root of L squared plus W squared squared again. So D squared is equal to H squared plus L squared plus W squared And that means d is equal to square root of h squared plus l squared plus w squared. So that's where the formula comes from. So did any of you guys have questions about what we just did? Like how we found the formula? Okay. This isn't, you don't need to know this, but it just helps you get a sense of how to work out 3D problems. And you might forget this formula, so if you forget it, you can always just derive it by yourself. Okay, anyways. I have two problems here. I don't think they'll take 3 minutes, but regardless, I'll give you the time. And in both problems, I'm asking for the length of the space diagonal D. And you don't have to write your answers in decimal form. You could leave them in simplified radical form. I think we can go over the problems now. Yeah, so we know that, wait, Yeah, so you guys both got both problems right. So remember that d squared is equal to L squared plus W squared plus H squared. And from there, you just plug in the values. L is equal to 20, W is equal to 6, and H is equal to 6 again. So you get d squared is equal to 20 squared plus 6 squared plus 6 squared, which is 472. And then d is equal to 472. And remember that it's not plus minus square root of 472, since it's not possible for the length of any side to be negative. And then for this, it's the same thing. You guys both said that d is equal to square root of 3. So I think we are fine so far. We went faster than I anticipated, so I'm just gonna pull up the second part of the lesson I planned. And if you guys can turn your cameras on, that would be good. If not, that's also okay, but it would be preferable. Okay. Happened. Can you guys see my screen? Okay. So now we're going to be talking about something called the law of cosines. So what the Pythagorean theorem helped us do was solve for any side length of a right triangle. So for example, if someone gave us something like this, we could use the Pythagorean triple to find what this side length over here is, because we know that this triangle is right. But let's say someone gave us a triangle that doesn't have a right angle necessarily. So we might have this angle alpha, and then they tell us that this side length is 3, and this is 6. And they give us what this angle is. And they want us to solve for this side length over here. So for this, we can't use the Pythagorean theorem since the angle alpha isn't a right angle. But what we use instead is just a generalization of the Pythagorean theorem, and that's the law of cosines. So are you guys familiar with what cosine is over here? Okay. Maybe if not, I should review trigonometry before we do this. Okay, hold on. Okay, so I don't think trigonometry gets covered until geometry, but it's really important, so I'm going to go over. Basically, when we have a right triangle, we define certain ratios or relationships between the side lengths of the triangle. So A, B, and C. Let's say this angle is capital B, and this angle is capital A. So we say that cosine of any angle, so cosine of A, for example, would be the length of the adjacent side, which is B, over the length of the hypotenuse. Or, like I just said, adjacent over hypotenuse. So just remember that adjacent means the side length that's touching the angle. So for angle A over here, the side length that's touching the angle is side B. Okay? And then similarly, we define something called sine as the opposite side, or the side that's opposite to the angle, over the hypotenuse. So AC equals to opposite over hypotenuse. So as, let's say we're taking the sine of angle A, the side that would be opposite to angle A would be the side length lowercase a, since it's not touching angle A at all. And then the hypotenuse would obviously be C. So opposite over hypotenuse would be equal to A over C. Then the last important trigonometric ratio we have is called tangent. And we say tan of A is equal to sine over cosine. Or opposite over adjacent. And for angle A, this would be equal to A over B. Okay, so let's work out a quick example before we move on. So let's say this is 3 root 3, 6. And let's say this is angle A, and this is angle B. So what is the sine of A? What is the cosine of B? And what is tangent of B? Okay, so I'll give you guys like 3 minutes to work these out. Okay, so I'm just going to go over sine of A quickly. So remember that sine of A is equal to opposite over hypotenuse. So when we're asked for the sine of a specific angle, so the angle over here is A, we want to find the side that's opposite to the angle and the side that's the hypotenuse. So which side would be opposite to angle A? Or like what is the side length of the side? Like in this triangle over here. Yeah, so the opposite side would be 3 over root 3, right? Because remember that the opposite side to an angle is the side that isn't touching the angle. So if we look here, the side 3, that's touching angle A. The side 6, that's also touching angle A, right? Like these two, they're in contact with the angle. But the side 3 root 3, that's completely opposite to the angle. So the opposite side would be 3 root 3. And then what would the hypotenuse be? Yeah, the hypotenuse would be 6. So the sine of the angle is opposite over hypotenuse. So opposite over hypotenuse would be 3 root 3 over 6, which is equal to root 3 over 2. Okay. So do you guys want to try these two parts again? Okay, let me review the definition cosine also. Maybe it might have been a bit confusing because I used b over here and over here. So let's go over that again. Okay, so let's call this angle over here x and this angle over here y. So cosine, or let's cosine of x is equal to the ratio adjacent over hypotenuse. So the side that's adjacent to an angle x is the side that's directly in contact with the angle. So the side length b over here, that's directly in contact with the angle x. So just think about adjacent as the side that's touching the angle. And that's not the hypotenuse, obviously. So for angle x, the two sides that are touching it are B and C. But we know that C is the hypotenuse, so it can't be the adjacent side. So that means B must be the adjacent side. So based on that knowledge, can anyone tell me what the adjacent side to angle Y would be? Yeah. Well, there's only one adjacent side. So the adjacent side, it's the side that isn't the hypotenuse that's touching the angle. Yeah, so it'd be A. Yeah. So based on that, we can say that cosine of x is equal to adjacent over hypotenuse. So we just said that the adjacent side to angle x is B. And we know that the hypotenuse of this whole triangle is C. And then similarly, we can say that cosine of y is also equal to adjacent over hypotenuse. So what we just said is that the side that's adjacent to angle y is A. And again, the hypotenuse is C. Yeah, it's A over C. Now for sine, it's basically just the opposite of cosine. So when we want the sine of an angle, we want the side that's opposite to the angle. So let's say we are looking at sine of x. The side that's opposite to an angle is the side that isn't touching the angle at all. So can someone tell me what the side opposite to angle x would be? So opposite sine of x is equal to opposite over hypotenuse. So it would be equal to A over C. And then similarly, for sine of y, we also want opposite over hypotenuse. So for angle y, what's the side opposite to it? B. So sine of y would be opposite over hypotenuse, which is B over C. Yeah. And then tan, let's say tan isn't that important because it's just sine over cosine. Sine x over cosine of x. And that's just equal to opposite over hypotenuse. Okay, so did anyone have any questions about the definitions of trig ratios? Okay. So if not, let's go over cosine of b. So hopefully this shouldn't take that long anymore. So can someone tell me what cosine of b would be? And remember, cosine is adjacent over hypotenuse. Yeah, so I think you meant half root 3, right? Yeah. So adjacent over hypotenuse, and the side adjacent to angle B is 3 root 3. And the hypotenuse is 6. And you can simplify this fraction so that it's root 3 over 2. Okay. And then before we end, can someone tell me what tan of B would be? Yeah, so tan of B would be opposite over hypotenuse, sorry, opposite over adjacent. I was asking like for this triangle over here. So the opposite side to angle B is the side that isn't touching angle B at all. And that's 3. And the side adjacent to angle B is the side that is touching angle B. And that's 3. Yeah, so that would be 1 over root 3. And then you can rationalize the denominator to root 3 over 3. Okay, so did that make sense? Okay. I think that's all we have time for today. If you guys have any other questions, you could stay after. If not, thanks for coming, and you're welcome to leave.